Hello students, welcome to Anne's classes. Let's do prime numbers and composite numbers today. Prime numbers and composite numbers. What are prime numbers? Prime numbers are natural numbers that are divisible only by 1 and itself. All natural numbers start from 1. And all numbers that are natural and are divisible only by 1 and itself are called prime numbers. So let us look at numbers 1 to 10. So I have numbers 1 to 10 here. Let's look at the number 1. 1 is divisible only by 1, isn't it? 1 ones are 1. So it has only one factor. 2 is divisible by 1 and 2. 1 2s are 2. So 2 has two factors, 1 and 2. 3 is divisible by 1 and 3. Two factors again for 3. What about the number 4? It's divisible by 1, 4 and 2. 1 4s are 4. 2 2s are 4. So as you can see, the number 4 has three factors, 1, 4 and 2. Let's look at the number 5. 5 is divisible only by 1 and itself, 1 and 5. It has only two factors. 6 is divisible by 1 and 6. 1 6s are 6, 2 3s are 6. So 6 has 4 factors. The number 7 is divisible only by 1 and itself. 1 7s are 7. 8. 1 8s are 8. 2 4s are also 8, isn't it? So 8 has 4 factors. 9 is divisible by 1 9 and 3. 1 9s are 9. 3 3s are 3. 10 is divisible by these numbers. 1 10s are 10. 2 5s are 10. So 10 has 4 factors. Now what are prime numbers? Prime numbers are numbers that have only two factors. That is 1 and itself. Can you see blue? The lines in blue, the arrows in blue. 2, 3, 5 and 7. These have only two factors, 1 and itself. So these numbers are called prime numbers. Now we are going to find prime numbers between 1 and 100 using a special technique. We are going to use the sieve of Eratosthenes. The sieve of Eratosthenes will help us find prime numbers between 1 and 100. So the first thing we need to do is write down all natural numbers between 1 and 100. Write down all natural numbers starting from 1 up to 100. Now I have struck off 1 because 1 has only one factor as we saw. Okay. Now listen carefully. Using the sieve of Eratosthenes, we are going to find all the prime numbers that are there from 1 to 100. So first step, circle the number 2 and cross out all the even numbers. Other than 2, we've circled 2. Cross out all numbers that are divisible by 2. These are the even numbers. So let's do that. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98 and 100. So this is the first step. We circled 2 and crossed out all the even numbers that are divisible by 2. So what are we doing here? We are removing all numbers which are not prime, and finally what is left will be only prime numbers. So this is the first step. We've already removed all the even numbers, so the numbers have become lesser now. Okay, so let's go on to the next step. Circle 3 and now cross out all the numbers that are divisible by 3. One is all the numbers that are in the tables of 3. Another way of finding out if a number is divisible by 3 is by adding up the digits, and if it is in the tables of 3, it is divisible by 3. So I've circled 3. I'm going to cancel out or cross out all the numbers that are in the tables of 3. Some of the numbers have already been crossed out because they were in the tables of 2 also. So let's start. 3 ones are 3, which we have circled. Now we're going to cross out. 3 twos are 6. It's already crossed out. Can you see after 5? It's crossed out. 3 threes are 9. 3 fours are 12 is crossed out. 3 fives are 15 in the second row. 3 6 are 18 in the second row has been cancelled. 3 sevens are 21 in the third row. 3 eights are 24 cancelled. 3 nines are 27. 3 tens are 30 crossed out. 3 elevens are 33. 3 12s are 36 already crossed out. 3 13s are 39. Okay, now there are some numbers left, and if you're not sure of the tables of 3 beyond 3 13s, all you have to do is add up the digits. So let's go to row number 5 starting with 41. Okay, add up the digits. 4 plus 1 is 5. It's not in the tables of 3. 43. 4 plus 3 is 7. It's not in the tables of 3. 45. 4 plus 5 is 9. 9 is in the tables of 3. So cross out 45. 47. 4 plus 7 is 11. It's not in the tables of 3. Leave it. Next number that is there is 49. 4 plus 9 is 13. It's not in the tables of 3. So leave it. Go to the next row. 51. 5 plus 1 is 6, and 6 is there in the tables of 3. That means 51 is divisible by 3. So cross out 51. The next number is 53. 5 plus 3 is 8. It's not in the tables of 3. Leave it. Next number is 55. 5 plus 5, 10. Not in the tables of 3. The next number, 5 plus 7, 12. It is there in the tables of 3. That means 57 is divisible by 3. Cross it out. Next number, 59. 5 plus 9 is 14. It's not in the tables of 3. Let's go to the next row. 61. 6 plus 1 is 7. Not in the tables of 3. Next number, 63. 6 plus 3 is 9. 9 is in the tables of 3. So cross out 63. Next number, 65. 6 plus 5 is 11. Not in the tables of 3. Next number, 6 plus 7 is 13. Not in the tables of 3. Next number, 69. 6 plus 9 is 15. And 15 is there in the tables of 3. So cross out 69. Next row, 71. 7 plus 1 is 8. Not in the tables of 3. Next number, 73. 7 plus 3 is 10. Not in the tables of 3. Next number, 75. 7 plus 5 is 12. And 12 is there in the tables of 3. So cross out 75. Next number is 77. 7 plus 7 is 14. It's not in the tables of 3. Next number is 79. 7 plus 9 is 16. It's not in the tables of 3. Next row, 81. 8 plus 1 is 9. Yes, 9 is in the tables of 3. So cross out 81. Next number is 83. 8 plus 3 is 11. Not in the tables of 3. Next number is 85. 8 plus 5 is 13. Not in the tables of 3. Next number 87. 8 plus 7 is 15. And 15 is there in the tables of 3. So cross out 87. The next number in that row is 89. 8 plus 9 is 17, not in the tables of 3. Let's go to the last row, 91. 9 plus 1 is 10. 10 is not in the tables of 3. The next number is 93. 9 plus 3 is 12, and 12 is there in the tables of 3. So let's cross it out. 95. 9 plus 5 is 14. It's not in the tables of 3. Next number 97. 9 plus 7 is 16. Not in the tables of 3. Next one 99. 9 plus 9 is 18, which is there in the tables of 3. So let's cross out 99. Okay, so what have we done so far? First we circled 2 and crossed out all the numbers in the tables of 2. Then we circled 3 and crossed out all the numbers in the tables of 3. Now, can you see there are only few numbers left, and some of these are prime numbers. So what are we trying to do? We are trying to get only the prime numbers. So at the end, when you finish out all the crossing out, what is left will be prime numbers. So we finished with 2, we finished with 3. Let's go on to the next number, 5. So circle 5. Now cross out all the numbers in the tables of 5. That's easy, isn't it? You know the tables of 5. So 5 2s are 10, already crossed out. 5 3s are 15, crossed out. 5 4s are 20, after 19, crossed out. 5 5s are 25. Let's cross out 25. Okay, let's cross out all the numbers in that row. 25, then 35. 45 is crossed out. 55, 65, 75 is crossed out, 85, 95. Can you see there are only few numbers left? All the numbers that are in the tables of 5 we have crossed out. Very few numbers left. Okay, now the only number left in the top row, topmost row is 7. So let's circle 7. And we are going to cross out all the numbers that are there in the tables of 7. So let's say our tables of 7. 7 1s are 7, we have circled. 7 2s are 14. Is it there? No. Crossed out. 7 3s are 21. Crossed out. 7 4s are 28. Crossed out. 7 5s are 35. Crossed out. 7 6 are 42. Crossed out. 7 7s are 49. 49 is still there. Let's cross it out. 49. Okay. 7 8s are 56. Crossed out. 7 9s are 63. Crossed out. 7 10s are 70. Crossed out. 7 11s are 77. It's still there. Let's cross it out. Okay. 7 12s are 84. Crossed out. 7 13s are 91. Let's cross it out. Okay. So now we have a few numbers left, and these are the prime numbers. Okay. Can you see we've crossed out all the numbers that are in the tables of 2, 3, 5 and 7. Whatever numbers are now left are the prime numbers. So this is the sieve of Eratosthenes, where we remove all numbers and what is left behind is only prime numbers. So let's see what the prime numbers are. 2, 3, 5, 7 in the first row. Second row, 11, 13, 17, 19. Next row. 23, 29. Next row. 31, 37. Next. 41, 43, 47. Next row. 53, 59. Next row. 61, 67. Next. 71, 73, 79. The next row, 83, 89, and the last row, 97. So all the numbers that we have circled are the prime numbers. So did you see how we use the sieve of Eratosthenes? We wrote all natural numbers from 1 to 100, and slowly we started removing all the numbers which are not prime numbers. And what is left behind are the prime numbers. So can you see that? These are all the prime numbers between 1 and 100. Numbers which have more than two factors are called composite numbers. So right now we saw prime numbers because they have only two factors. What if they have more than two factors? They're called composite numbers. So if they're not prime numbers, they're composite numbers. Let's see some examples. 4. What are the numbers that give you 4? 1 fours are 4, 2 twos are 4. So 4 has three factors, more than two factors, so it's a composite number. 6. 1 sixes are 6, 2 threes are 6. 6 has four factors. The number 8, let's see. 1 eights are 8, 2 fours are 8. More than two factors, so it's a composite number. 9. 1 nines are 9, 3 threes are 9. Three factors, it's a composite number. 10. 1 tens are 10, 2 fives are 10. So can you see these numbers 4, 6, 8, 9 and 10 have more than two factors. So numbers which have more than two factors are called composite numbers. What about the number 1? It has only one factor. 1 ones are 1, isn't it? So it is neither prime nor composite. It is a unique number. Let's hear some fun facts. Every prime number is greater than 1. Which is the smallest prime number? 2. The smallest prime number is 2. And 2 is the only even prime number. All the other even numbers are composite numbers. Between 1 and 100, there are 25 prime numbers. We use a sieve of Eratosthenes and we found out that there are 25 prime numbers between 1 and 100. The number 1 has only one factor, which is 1 itself. Thus, 1 is not considered a prime number. 2 and 3 are the only consecutive prime numbers. That means prime numbers that come one after the other. 2, 3, they come one after the other. None of the other prime numbers come one after the other. Twin prime numbers. What are twin prime numbers? Is the pair of prime numbers that differ by 2. That is, if you minus them, the answer will be 2. Examples. 5 and 7 are prime numbers. 7 minus 5 is 2. So it's called twin prime. When you minus, if the answer is 2, they are called twin prime. 11 and 13 are prime numbers. 13 minus 11 is 2. 17 and 19 are prime numbers. 19 minus 17 is 2. So you have prime numbers that differ by 2 called twin primes. Every even number that is greater than 2 is a composite number. And the smallest composite number is 4. So I hope you have understood, children. Thank you. Let's do multiples and factors exercise 6.2. This is on page number 76. The first question is, which of the pairs are co-prime? Now, what is the meaning of co-prime? Let's do the first sum and you will understand the meaning of co-prime. So the first thing that we need to do is look at the pair of prime numbers. We have 15 and 33. Now we have to find the factors of 15. That's the first step. So let's find the factors of 15. Now what are all the numbers that multiply to give you 15? Like you can start with 1. 1 into 15 is 15. Then you go to 2. Nothing into 2 will give you 15. So go to 3. 3 into 5 is 15. What else will give you 15? 5 into 3, but we already have 5 into 3 here. So these are the factors of 15. So let's write down the factors of 15. We have 1, 3, 5 and 15. Now let's take the next number 33 and write the factors of 33. So what are the factors of 33? Starting with 1. 1 into 33 is 33. 2, no, now 3. 3 into 11 is 33. Will anything else give us 33? Nothing else will give us 33. So what are the factors of 33? 1, 3, 11 and 33. So let's write that. So 1, 3, 11 and 33. So what is the first thing we did? We found the factors of 15. Then we found the factors of 33. Now we're going to find the common factors. So here there is 1 and 3 that are common to both. So let's circle that. So 1 is common. We have 1 for both and we have 3 also. Now so the common factors are 1 and 3. Now, if these two numbers are co-prime numbers, then their common factors will be only 1. They will not have any other common factors. So here, as you can see, for 15 and 33, there are two common factors. So 15 and 33 are not co-prime numbers. Remember, if they are co-prime, they will have only 1 as their common factor. So we'll write 15 and 33 are not co-primes. Second one here. B, 24 and 29. Now let's see again factors of 24. So what are the numbers that multiply to give you 24? 1 into 24 is 24. Let's go to 2. 2 into 12 is 24. Let's go to 3. 3 eights are 24. 4. 4 sixes are 24. Then we have 6 fours are, and 6 fours are already there, so we stop with this. So these are all the factors of 24. Let's write it down. 1, 2, 3, 4, 6, 8, 12 and 24 are the factors of 24. Now we must write the factors of 29. The factors of 29. Now 1 into 29 is 29. Will any other number give us 29? No other number will give us 29. So what are the factors? 1 and 29. So let's write 1 and 29. Next step is look at the common factors. So what are the common factors here? You can see only 1 is common and there's nothing else that is common. Now here we have 29. Do we have 29 there? We don't have. So only 1 is common. So the common factor here is only 1. Such numbers like 24 and 29 whose common factor is only 1. Such numbers are called co-prime. So we can say 24 and 29 are co-primes because their common factor is only 1. Next one, 34 and 57. Let's write the factors of 34. So let's write down 34 here and get the factors. So 1 into 34 is 34. Then can we do it by 2? 2 into what is 34? To find out 2 into what, you take 34 and you divide it by 2. 2 ones are 2 minus 3 minus 2 is 1. You bring down 4, 14. 2 sevens are 14 minus 0. So here this number 17, if you multiply it by 2, you get 34. So let's write it there. 2 into 17 is 34. Now, no other number will give us 34. So what are the factors of 34? 1, 2, 17 and 34. So let's write it there. 1, 2, 17 and 34 are the factors of 34. Now let's take the next number 57. So 1 into 57 is 57. Then we cannot multiply by 2 because this is not an even number. So let's see if we can divide this by 3. So let's take 57 and divide it by 3 and see 3 ones are 3 minus 5 minus 3 is 2, 7, 27. 3 nines are 27, yes. Okay, so here we have 0. So now 3 into 19 will give us 57. So let's write it there. 3 into 19 is 57. Now no other number will give us 57. So what are the factors of 57? 1, 3, 19 and 57. Let's write them down. Factors of 57 are 1, 3, 19 and 57. Next step is to find the common factors. As you can see, only 1 is common. None of the others are common. So let's write 1 as a common factor. So can you see only 1 is common? That means these two numbers are co-prime numbers because their common factor is only 1. Let's write 34 and 57 are co-primes. Question D, we have 18 and 67. So let's find the factors of 18 first. So we have 18. Let's find the factors. So 1 into 18 is 18. Let's go to 2. 2 nines are 18. Let's go to 3. 3 sixes are 18. That's it. Nothing else will give us 18. So what are the factors? 1, 2, 3, 6, 9 and 18 are the factors of 18. Now the next number is 67. Let's find the factors of 67. So 1 into 67 is 67. Now no other number will give us 67. So the factors of 67 are just 1 and 67. So let's write that 1 and 67. Next step, find the common factors. So here as you can see, only 1 is common. So this is the factor that is common to both. So what is our answer? 1. And so these two numbers, 18 and 67, since their common factor is only 1, they are co-prime numbers. So 18 and 67 are co-primes. Next one is 14 and 52. So first step, let's find the factors of 14. So 1 into 14 is 14. Then we can go to 2. 2 sevens are 14. Nothing else will give us 14. So 1, 2, 7 and 14 are the factors of 14. Next step, factors of 52. So 1 into 52 is 52. Then we can go to 2. 2 into 26 is 52. Then it is not divisible by 3, but by 4 we can divide it. 4 ones are 4 and 4 threes. That means 4 into 13 is 52. That's it. Only this many numbers will give us 52. So let's write the factors of 52. 1, 2, 4, 13, 26 and 52. Now let's pick out the common factors. So here you can see 1 is common, 2 is also common. So 1 and 2 are the common factors. That means 14 and 52 are not co-prime. If they are co-prime, only 1 will be their common factor. So let's write the answer. 14 and 52 are not co-primes. Question 2. Which of these numbers are prime and which are composite? Now I hope all of you have understood prime and composite numbers by watching the video that was put in the beginning of this. So one way to find out is all even numbers. 36 is an even number, isn't it? All even numbers are composite numbers other than 2. 2 is the only even number which is prime. All the other even numbers are composite numbers. So 36 is a composite number. Another way to find is by finding the factors. So let's find the factors of 36. 1 into 36 is 36. Now if you take 2, 2 into 18 is 36. If you take 3, 3 into 12 is 36. 4 nines are 36. And 6 sixes are 36. See, so many factors of 36. Let's write it down. 1, 2, 3, 4, 6, 9, 12, 18 and 36. These are all factors of 36. Now what are composite numbers? If they have more than two factors, they are composite numbers. Prime numbers will have only two factors. 36 has so many factors. So 36 is a composite number. So there are two ways of finding. Just by looking at the number, when you know it's an even number, remember it will be a composite number. Otherwise, you can find all the factors and see that if a number has more than two factors, it is not a prime number, it is a composite number. Question B is 37. So let's write the factors of 37. Now 37 has only two factors, 1 and 37 itself. That means 37 is a prime number. A number which has only two factors is called a prime number. A prime number which has more than two factors is called a composite number. Now question C. Now what are the factors of 31? 31 also has only two factors, 1 and 31. That means 31 is a prime number. 59. What are the factors of 59? The factors of 59 are only 1 and 59. So there are only two factors. If there are only two factors, then 59 is a prime number. So 59 is a prime number. Next one, 29. Is 29 a prime number? Let's find the factors. The factors of 29 are only 1 and 29. So since it has only two factors, it is a prime number. 29 is a prime number. Next question, look at this. 17 and 71 are prime numbers in which both have the same digits. Can you see? 1771. Both have 17. But the order is different here, isn't it? Now, we are asked to find such prime numbers between 1 and 100. So, there are two prime numbers like this. Are there more prime numbers? That is the question. And find such prime numbers between 1 and 100. The first thing to do is write all the prime numbers between 1 and 100. So, let's do that. So, let's begin. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41. Let's continue. 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. So these are all the prime numbers between 1 and 100. Now we need to find numbers like this, 17 and 71. The reverse, the order is different, but the digits are the same. So let's look for two-digit numbers. Now 13 and 31. Can you see that? So we have 13 and 31. So let's write that also down. So we have 13 and 31. That is one set of numbers, 13 and 31. Do we have some more like that? Let's go ahead and see. 17 and 71 is already there. Now 19 and 91. No, 91 is not a prime number. 23 and 32. No, 32 will become an even number, isn't it? 29 and 92 will become an even number. 37 and 73. Yes, can we see that? Here we have 37. Let me use another color. So here we have 37 and we have 73. So that is the second set. Let's write that. 37 and 73. Now let's go ahead and see. Now 41 and 14. No, 14 will become an even number. 43 and 34, no. 47 and 74, no. 53 and 35, no. 59 and 95, no. 61 and 16, no. 67 and 76, no. 71 we already have in the question. 79 and 97, yes, can you see? 79 and 97. So this is the next one, 79 and 97. So let's write that. The third set is 79 and 97. Next we have 83, 38 no, 89, 98 no. So these are the three pairs of numbers in which both the digits are the same but the order is different, and these are between 1 and 100. Now children, it will be good for you to learn all prime numbers between 1 and 100 because you can answer questions like these. So let's go ahead. Question 4. Find prime numbers between 20 and 50. So again here also first let's write down all the prime numbers between 1 and 100. So 2, 3, 5, 7, 11. Now you should know all these so that it's easy for you to write it down. 13, 17, 19, 23, 29, 31, 37, let's continue, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. So these are the prime numbers between 1 and 100. Here we've been asked to write between 20 and 50. So now from here up to 50 means till here. So let's write down all these numbers in our answer. So in our answer, let's write down 23, 29, 31, 37, 41, 43 and 47. So this is our answer. Question C. Find prime numbers between 10 and 40 in which the sum of the digits is divisible by 2. That means we should have 1 plus 3 is equal to 4. That is, you have two prime numbers. When you add it up, your answer is 4. So we need to find prime numbers between 10 and 40. So first let's write down prime numbers between 1 and 100. Again, it's going to be so useful to learn this. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43. Let's continue. 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Now look out for prime numbers between 10 and 40. So between 10 and 40 means starting from here. So here 10 and 40 will be till here. And we should look for numbers that are divisible by 2. So let's do that. So first let's write down all the prime numbers between 10 and 40. So 11, 13, 17, 19, 23, 29, 31 and 37. Now where do we have numbers like this? 1 plus 3 is equal to 4. Okay, so adding up two prime numbers, the answer should be a number that is divisible by 4. That means it should be an even number. So let's look out for numbers like that. Okay, now I'm going to take the sum of the digits. Now 11 is 1 plus 1. 1 plus 1 is 2. So it's divisible by 2. So answer is 11. Take the next number 13. 1 plus 3 is 4. It's divisible. So 13 also. Now take 1 plus 7. 1 plus 7 is 8. 8 is divisible by 2. It's an even number. So we can write 17 also. Now let's take the next one, 19. 1 plus 9 is 10. 10 is also divisible by 2. So I can write 19. Let's take the next one, 23. 2 plus 3 is 5. So this is not giving us an answer that is divisible by 2. So we can't take 23. Let's take 29. 9 plus 2 is 11. 11 is an even odd number. It is not divisible by 2. Next take 31. 3 plus 1 is 4. So we can write 31 also. 3 plus 1 is 4. Then let's take 37. 3 plus 7 is 10. So that is also divisible by 2. So these are the numbers. When you add up their digits, you get even numbers, prime numbers between 10 and 40, whose sum of digits is an even number and is divisible by 2. So with this, children, we come to the end of this exercise. Thank you, children.